All right, in this video, we're going to do warm-up number 18. So number 1, you have a job that pays $19 for each hour you work. You are required to work between 20 and 40 hours per week. The function y equals 19x, where x is greater than or equal to 20 but less than or equal to 40, shows the relationship between the hours you work and your weekly pay. What is the domain and range of the function? So the domain of the function is our x values, right? It's always going to be our possible x values. And the range of a function, so our domain here is for our x value is going to be between 20 and 40. So if that's going to be our domain, the x is between 20 and 40, the only two answers are A and B that have the correct domain listed. So I'm only going to look at these two answer choices and I can ignore C and D. Now, it also asks for the range. The range of the function is always going to be all of our possible y values. And our y here is equal to 19x. So we have to plug in our minimum and our maximum x values in order to figure out our minimum and maximum y values, because then that will give us the range. So when I plug in my minimum value of 20, I know that the minimum y is going to be 380. And when I plug in my maximum value of x, which is 40, when I plug that in for x and I multiply that times 19, I get 760. Therefore, my range is going to be between 380 and 760, so my answer here is B. Number 2, which of the following describes the graph of the function f of x is equal to x squared plus x minus 12? The first thing I'm going to look at is my a term. My a term is equal to a positive 1, so that means my parabola is going to open up. Anytime I have a positive a term, that means my parabola is opening up. So I can immediately cross out C and D because it says that the parabola is opening down. So now I'm left with A and B. So I have a 50-50 shot, which on the EOC is a much better chance than a 25% chance. So let's keep working. So which of the following describes the graph of the function? So now we're looking at our intercepts, specifically our x-intercepts. So we're going to factor the equation to find our x-intercepts. So here's our equation, f of x is equal to x squared plus x minus 12. And if you remember correctly, we're going to use our factor puzzle, our cross puzzle. So we did our a times c. So our a term times our c term is going to be negative 12x squared. And then our b term is a positive 1x. So to find the factors that multiply to give us negative 12, but then add together to give us 1. So here are some factors that I listed here in a factor chart. And negative 3 and 4 are the factors that will add together to give me a positive 1, but multiply together to give me a negative 12. So now that I have my factor puzzle, my cross puzzle done, now I can identify my factors as x minus 3 and x plus 4. Okay, if I multiply these two factors together, I'm going to end up back with this quadratic equation. So that's why we factored. Now we're going to use our zero product property rule in order to find our x values. So x minus 3 is equal to 0. So x is equal to 3. And x plus 4 is equal to 0. So x is equal to a negative 4. So if I list that as an ordered pair, I have 3, 0 and negative 4, 0. So that means that my answer here is B. Moving on to question 3. The table below shows ordered pairs of a linear function. Based on this data, what is the slope of the line? To find our slope of a line, remember that slope is equal to y2 minus y1 over x2 minus x1, or our change in y over our change in x. So we're going to take these values from our table, these x and y values. See, I'm going to identify 1.5 as y2. -9 as my y1, 5 as my x2, and 0 as my x1. Now when I fill in all these values and I subtract, so what happens when I subtract a negative? I'm going to really be adding. So I end up with 10.5 divided by 5. Okay, if you don't have a calculator for this, you should still be able to estimate how many times 5 goes into 10. Well, 5 divides into 10 2 times, and then you have 0.5 divided by 5, which will give me 0.1. So my answer here is C, 2.1. So that's the slope of this linear equation here. All right, that's it for our bell work for today, number 18. Make sure you go and finish your reviews. Bye.